So that gets us to really the modern day. What are we doing about these challenges? What are we doing about the fact that we were dealt a shorthand in the Colorado River negotiations? What are we doing about the fact that historically we had used more water than we should have in securing our supplies? And what are we doing today to meet the infrastructure challenges that are facing our community? So the first thing we're doing, any good economist will tell you, in a supply and demand imbalance, you can do a couple of things. You can get more of something, you can use less of something, or you can secure your means of delivery. The first thing we've done is reduce the amount of water we use. Southern Nevada is a world leader in municipal water conservation. We have spent over $200 million to date paying people to take out grass. And not just paying people to take out grass, but to embrace the culture of living in the Mojave Desert. You can see the amount of sod we've taken out. If you take an 18-inch piece of sod, hopefully most of you have never rolled a piece of sod because you're not supposed to be putting it in. But if you had an 18-inch piece of sod and you wanted to roll it around, you could get 85% of the way around the globe with the amount of turf our community has removed. And the results of that program really speak for themselves. We have driven down our consumptive use of water just in the 21st century by 33%. You think about that. Across the community, across businesses, across homes, we have used, on average, 33% less water than we were using only 14 years ago. And what makes that number more astounding is our population increased by 25% over the same time period. So truly a monumental achievement by the community. We've also started taking care of the environment better in our own backyard. The Las Vegas Wash historically was fed by those spring flows that came off of the Spring and Sheep Mountains, and it grew substantially in the early phases of development because that wastewater was being put down the wash. So you ultimately had about 2,000 acres of wetlands out there. But the head cutting, the more water you put down a channel, the more you get head cutting, and that almost destroyed all of the wetlands in the Las Vegas Wash. But the community has come together. The members of the Water Authority, the federal government, the state government have got together to stop the head cutting, to build weirs, to slow the flow of water, and ultimately reestablish those wetlands in the wash. So you see, these are all the different weirs that have been constructed from '99 through 2014, and we're almost done. This one shows 3 kids, and I think there's 2 more. We have 3 more weirs, and we'll think we'll be done with construction in the wash by 2017. And you can see here the revegetation efforts. You can see when I talk about head cutting, this used to be flat up here, but once we put in a weir structure, you get the wetlands coming back in, and then a much more mature habitat. So these are, not only does this clean our water, it's a natural filtration system for the effluent that we're putting back down the channel, but it also provides an ecosystem for the plants and animals that have always called Clark County home. Resources. I mentioned that we're the agency that's in charge of planning for our water resources always 50 years into the future. In the cooperative agreement that formed the Southern Nevada Water Authority, it's a requirement that we take a resource plan to our board every single year so that we always have a 50-year rolling outlook for our resource plan. And we break our resources into 3 categories. We have permanent resources that we think will always be there. We have temporary resources, which are like a bank account. You put water in, but as you pull it out, it doesn't naturally replenish. And then we have future resources that we work on in the multi-decadal time frame. So our basic resources, our permanent resources, are the same that I've already shown you. We have Colorado River water, we have groundwater, and we have reuse. So that can be purple pipes, You don't see a lot of that in Henderson, but in the northwest part of the valley, we treat the water and use it for large turf applications or return flow credits. If it hits a drain, we put it back into Lake Mead, we can take it back out. Our temporary resources, and I won't spend a ton of time on this, but we've banked water all over the place. We've spent $600 million to date paying the state of Arizona to inject their unused water into their aquifer so that it's there for our future use when we need it. We've banked our unused water in California. We've injected over a full year's supply of water into our aquifer here in the Las Vegas Valley. And we've actually reached the point where we're not injecting any more water into our aquifer here, because I showed you the picture of the surface dropping down by 5 or 6 feet. We've injected enough water now that the water table has come back up, and in the northwest part of the valley, we're close enough to the surface where we could pop out swimming pools if we keep injecting it up there. So we're gonna stop that because they don't want that. And then future resources. And we have a groundwater project that we could bring water into the valley in the future if need be. Transfers, exchanges, desalination. We're constantly working to know that we can have resources at the end of the bridge that those temporary resources provide to us. And I'm going to go back just a sec to make one point about the temporary resources. We've banked 1.5 million acre feet of water in all these different places. So we have a full 8 years of supply banked in these different accounts across the western United States. So it's not a message that our community is used to hearing, but as we sit right here now in 2015, we have a really healthy water portfolio. We have good water in the bank, and we have pretty secure water in Lake Mead. And that's really what this shows. This, I'm going to show you two different versions of this. The demand line in our resource plan, we take the Center for Business and Economic Research at UNLV, we take their population projections, we embed our gallons per capita per day conservation goal into that to generate our demand line, and then we look out and see what our resources, both permanent, temporary, and future, will do. And what this assumes is that current SeaBur population projection, and that we won't have any shortages on the Colorado River, which I've shown you the hydrology, and you probably shouldn't assume you're not going to have shortages on the Colorado River. But if you had a modest growth rate combined with stable hydrology, we don't need any future resources until out here in the 2060s. Now, if we change a couple of those variables, if we double the SeaBur population growth rate, we assume we have a shortage on the Colorado every single year, and not only do we have one every single year, but it's double the amount that's currently provided for in federal law. You see the 40,000 acre feet up here. Under the 2007 operating agreements that control the 7 states' use of the Colorado River, the maximum shortage Nevada can take is 20,000 acre feet. So if we have one every year and we double it and conserve a little more water, we drive down our gallons per capita per day from 199 to 185, we still have solid resources through the mid-2040s, giving us several decades to work on how we're going to fill that gap in future resources. Infrastructure. So these are our two intakes that exist and are operational today. There's a couple of key elevations, 1050 and 1000. So when Lake Mead is completely full, it's at mean sea level of 1220. So we've always assumed for decades that these intakes are deep enough to survive even the worst droughts on the Colorado River. In 2004, we put a snorkel onto that upper intake, because by 2004 the drought was bad enough that it was dropping down, that for water quality purposes, we wanted to be able to pull water from a deeper elevation with that upper intake. And then, because of the continuation of the drought, we ultimately began construction of a third intake. Now this is a project, and I was actually down in the tunnel today, that we drill a 600-foot access shaft here, and then with a tunnel boring machine, bore a 20-foot diameter tunnel all the way out to a new intake riser that is actually located where the Colorado River flowed before they built Hoover Dam. So this new intake riser is at the very deepest part of Lake Mead. So with the third intake in place, we'll be able to pull water from the coldest, deepest part of the lake at elevation 860, and that infrastructure should go online in midsummer. They've docked with the intake riser, and they're running out the chemical feed lines and should bring that online by about July. And that's critical, because here's Lake Mead in profile. And I mentioned, so we're full pool, you're at 1224. Today we're sitting at 1083, just for reference. But if we drop 33 more feet in the lake, we lose that upper intake. We can't pump water out of the upper intake. If we went down another 50 feet for that, we wouldn't be able to pump from the second intake. But at elevation 897, the Bureau of Reclamation can't release water out of Hoover Dam. It's called dead pool, and they can't get the water into the bypass tubes. So our lowest intake elevation, obviously we hope we never see the lake get to this critical of elevations, but if it does, we're guaranteed to always have almost 40 feet of water above our lowest intake.